Let's take a look at some tamp pressure data. So I wanted to understand how much tamping compresses a puck, and I wanted to use take some measurements to see how that happens. So I looked towards using Compresso as a transparent puck tamper, as well as something I could put some markers in to calibrate to see how much the coffee compresses. Now, this isn't ideal in the sense that it's a lot taller than a coffee puck in a normal espresso machine, but it's easier to measure because it goes up taller. So I put coffee in a few grams at a time, and then I put a piece of paper marker to mark where that was. Then I used a scale. I used a kitchen scale that went up to 5 kilograms, and I took two synchronized videos as I slowly compressed the puck. So then from here, I was able to see how much the puck compressed using lines on the images. So if I marked where the marker was between the two images, then I could count how many pixels down it moved. So I went a step further and I calibrated those pixels to tell me actual travel distance, so I could better understand puck compression. So I looked at these couple areas, the top, middle, and bottom. So they were split up in 3 gram increments, and I got to see how they compressed. So one thing that was neat about this experiment is it showed that compression happens at the top and the bottom at the same time, because that's how the force of compression works. So this is just the raw data. As tamp pressure goes up, the height of the slice reduces, and it kind of flatlines here. So I looked at the percentage of compression that had occurred. So compared to the total amount that you could compress the puck, what tamp pressure gave you what percentage of compression. And so it was kind of interesting to me that when you're at just a few pounds of pressure, you've compressed the majority of the puck, which is probably why previous studies have shown that there isn't much of a difference between 5, 10, 20, and 30 pounds of tamp pressure with respect to extraction yield. So overall, it's about, by the time you get to 3 pounds of tamp pressure, you've hit 80% of however much you're going to compress the puck. And so to compress the puck 10 more percent takes going from 3 pounds to 20 pounds, which is pretty incredible. So this is one piece of information, and it informed how hard I was tamping the puck. And for myself, I backed off on my tamp. I was more concerned about a level tamp, if anything. And I usually aim for about 300 grams of tamp pressure. So just a little over half a pound. So in this case, you're getting with that half a pound, you're getting about 20% compression. But I found that part of the issue with compression and tamping is that there is some space needed when coffee hasn't fully degassed. Otherwise, the bubbles themselves start to get in the way of extraction. So the takeaway from this is that you should try different tamp pressures yourself and see if you notice a difference, because you may not. But you also might like a calibrated tamper or the ritual of doing a hard tamp against a counter, and that's okay too. So I'm hopeful that this data will shed a bit of light on what's going on inside the puck.